We're going to look at where the triangle proportionality theorem comes from, what it is, and how to apply it. If we have two triangles, the smaller triangle with the bigger triangle, these two triangles are similar because they both share an angle, so that angle is congruent in both triangles by the reflexive property. And because these two sides are parallel, then these corresponding angles are congruent. Or you could have said the same thing here, which means A to A plus C to the longer side equals B, other side of the smaller triangle, to B plus D. But now we're going to do a little bit of algebra. So we're going to cross multiply and distribute and subtract AB from both sides. BA is the same as AB, so BA minus AB is going to cancel. And divide both sides by CD. So the D there cancels and the C there cancels. We're left with A to C equals B to D. So that's A to C equals B to D. That's the triangle proportionality theorem. So if a line parallel to a side of a triangle intersects the other two sides, so we have a line parallel to another line in the triangle and it intersects these two sides, then it divides those sides proportionally. So it divided this side and this side proportionally. So we can skip all this middle work now and use that theorem when we have a side like this. Looking at the first example, if we want to find Pn, we can set up the triangle proportionality theorem. X to 3 equals 5 to 2. So that's one side of the smaller triangle to this part equals the other side of the triangle to this part. And we can cross multiply and we get 7.5. The next one, find Mn. So instead of finding this first, we don't need to do that. We can just find the longer side using not this formula anymore, but going back to this formula that we started with. One side of the triangle to the longer side equals another side to its longer side. 8 to 13 equals 10 to x. And now once we have x, that'll be our final answer. So we could have set it up the other way like we did in this triangle, where we could have done 8 to 5 equals 10 to x, and then we would just need another step at the end where whatever we got here, we'd have to add it on to 10, and we get the same thing. Also, the converse of this theorem is true. So if a line divides two sides of a triangle proportionally, then it's parallel to the third side. So are KL and MN parallel? Well, let's see if MN divides the sides proportionally. Is 42 to 21 equal to 30 to 15? 42 divided by 21 is 2. 30 divided by 15 is 2. So because they equal, it was divided proportionally, making these two sides parallel.